Okay, this was the last question that I asked you at the end of the previous video. Given this information, how can you calculate probability greater than -1? So let's go back to Excel. So the first way, there are two different ways. One is to use the probability smaller than -1. So probability smaller than -1 is excuse me, 15.866%. So if you take 1 minus that, and this probability will be the probability greater than -1. Okay? And what you can find here is that probability is actually the same as probability smaller than +1. So probability greater than -1 is same as probability smaller than +1. So that is because they are symmetric. So you may use this, or you may use this symmetry. So here, what I'm doing here is probability greater than something is 100% minus smaller than the same thing. Okay? So probability greater than, smaller than should be the same thing. And so using that, you can calculate probability this way by taking 1 minus this probability. Or you may use the symmetry. So probability greater than -1 is the area here. If you exactly flip as a mirror image, then you are going to get this guy, which is probability up to 1, below 1. So instead of calculating this one, you can calculate this one. Main point here is that the Excel gives you only the probability smaller than something, right? There is no other formula calculating greater than something, but you can just use one of these two methods to calculate probability greater than something, right? You have to memorize that CDF is based on probability smaller than something, so you have to use that information to convert the information into the probability you want. Okay, then the next question. Similarly, how can you find probability between plus and -2? Try this. Stop the video and use Excel and calculate this probability. Try to calculate that probability. Okay, I'm going to show you the answer on Excel. So what we want to do here is we are going to use this and this. We will take their difference. Then this is the answer. So probability smaller than 2 is 97 point something percent. But we have to exclude the outcomes even smaller than -2, right? So their difference is the numbers outcomes between greater than -2 but smaller than +2. So this is how you can do it. Or if you want to use symmetry, what you can do here is probability between -2 and +2 is like this. Out of 100%, you subtract probability smaller than -2. Minus, you have to subtract probability greater than +2, like this. Okay, then you get the same number. This is 100% minus probability z is smaller than -2 minus probability z is smaller than greater than +2. So if you trim out two tails, outside plus -2, tails are trimmed, then also you get the same number. It does not matter whatever you use. Usually this is easier. Okay, then remember this was what I explained earlier, to calculate probability between two numbers, you can take difference of the CDFs at those 2 points, right? Then you are going to get probability in between them. Think about the area, okay? So a larger area is like a probability up to 2 is larger area, and then you subtract this much. Then you are going to calculate probability in between these two numbers. By the way, this number is commonly used, 95.445%. So approximately, we are going to use this number later quite often. Rule of thumb, 95% of 95% of outcomes lie between plus and minus 2. So this rule of thumb is used a lot in many applications. So I'll keep that in mind. 95% rule plus minus 2. Okay. Another thing here is, so far it was pretty straightforward. There was nothing super difficult or complicated. But what is a little more complicated is going the other way. So far, I gave you number A, a value for A, and then I asked you to calculate P. But you go the other way. What if I give you probability P and then ask you to find A that satisfies this equality, right? That is natural because f is a function, f is a function, so we are going the other way, inverse. We would like to calculate the inverse of the CDF, which is percentile, right? Remember, think about this. Probability below A is P%. Then we say A is P percentile. Bottom, P percent value. That is P percentile. So 100 percentile is maximum, 0 percentile is minimum, 50 percentile was the median. So in that way, you are going to you can think about inverting the CDF. Like given probability, find the value, right? 0% is the smallest, 100% is the largest. How can we do that? Let's go to Excel. So what we are going to is, well, I will show you, like say, 10%, 25%, 50%, 75%, and 90%. I will give you those percentiles, right? So I will write this way: 10 percentile, 25 like first, quartile, median, and third quartile, and 90 percentile. These are what I'm going to demonstrate. The difference here is you are going to use another formula, norm.s.inv. This is the difference. Inverse, INV stands for inverse. Standard, normal, standard, inverse. So standard, normal, inverse, it returns the inverse of the standard, normal, cumulative distribution, right? And what you enter here is, I will just, there is only one argument, which is the probability. So I'm going to enter this guy, like this. Then 10 percentile of a standard normal distribution is minus 1.28. Usually, we will cut off at the second decimal place. And similarly, norm.s.inv and probability. Probability, I will enter this, close the parenthesis. You get this number. First quartile is minus 0.67. In that way, I'm going to continue. And then, as expected, the median is 0, right? Median should be 0 because normal distribution is symmetric about 0, about the mean, and the mean is 0. And first quartile and third quartile are also symmetric because everything is symmetric. 10 percentile, 90 percentile are symmetric because they are symmetric. The normal distribution is symmetric. Okay? And also you can see that as the probability increases, the percentile increases. Right? It is also natural. 0% is the lowest and 100% is the largest. So as the probability increases, the value should increase. So we learned two formula, norm.s.dist and norm.s.inv. So these two formulas are for standard normal distribution. So remember these two formulas. Back to slide. This is exactly what I just did. I didn't do 5 percentile. Let's do it. 5 percentile, you have to use 0.05 and 95 percentile. Just extend. You get these numbers. Minus 1.64 plus 1.64 are plus minus 5% value. Okay? Then like it is based on percentile definition, counting from the bottom, right? Counting from bottom. So 5 percentile means 5% from the bottom. And 95 percentile is 95 percentile percent from the bottom. But what if you flip the order? Can you find the top 10% value? If you count from the top, what is the 10% value? Pretty simple. So top 10% value means 10% from the top means 90% from the bottom. So the answer is 1.28. The reason why I'm giving you this obvious question is because different notation is used different places. So statistics is used. So first, let me show you this graph. So 1.28 is this point where this area is 10%. Okay, so this is equivalent to have 90% on the other side because always the total area is 100%. So if you know right hand side is 10%, then left hand side is automatically 90%. So counting from the top or counting from the bottom. Again, the reason why I'm telling you this confusing thing is because different places use different notation, even within statistics, because different theories are developed separately, independently, so they have different traditions. For example, in statistics, we often use this notation. Uppercase z is greater than lowercase z subscript alpha. Here, subscript alpha usually stands for probability from the top, right? So probability greater than this lowercase z should be alpha in this notation. So that is top 10% value, top alpha percent value. So in this notation, probability is calculated from the top. But usually the standard is calculating from the bottom, cumulative probability. But this has a different convention. It's annoying, but I don't have the power to change that. So you have to follow that. Anyhow, it is confusing, but idea is pretty simple. So probability z lowercase z alpha, in other words, if you count from the bottom, probability is 1 minus alpha. Probability is smaller than that point is 1 minus alpha, which is the cumulative distribution function. We are going to use this notation every chapter from now on. Maybe every chapter, like at least in the following 4 chapters, use this notation. So keep that in mind. It is counting from the top so that Z alpha is almost always positive because alpha is usually like 1%, 5%, 10%. So then Z, lowercase z, is usually positive. Then can you try this just to get used to this notation? Find, like, based on the percentiles, which is the Excel function, but you will need to find top 5% value. It's simple. The answer is 1.64. So when I say top 5% value on Excel, you have to find 95 percentile from the bottom. That is the confusing notation. Okay. Also, this is actually, in some sense, it is not much of a problem because in standard normal distribution, if it's positive, it is on the larger side. If it's negative, it's bottom side. So you can tell if it's counted from the bottom or the top. Also, usually later we are going to use it this way. So if we know top 5% value is 1.64, so it is top 5%, but at the same time, you can see that minus 1.64 is bottom 5%. So top 5%, bottom 5% are known as plus minus 1.64. That means 90% lies between plus minus 1.64. So even though we are counting from the bottom or the top, but later, in fact, what we are interested in is the middle values. So like we use top 5% value when we want to trim out top 5% and bottom 5%. So what remains is the middle 90%, right? I want you to connect like top 5%, bottom 5%, and middle 90% at the same time. And usually we want this guy. That is why I'm emphasizing this notation. It is confusing. So you get this idea. So we know, if you know that 1.64 is top 5%, then automatically bottom 5% is minus 1.64, and then in the middle there are 90% of outcomes. So this is usually the most important probability, middle side probability. Okay, so so far what I explained is based on the standard normal distribution. That means the mean and the variance are fixed at 0 and 1. We did not worry about different values. But of course, in practice, the mean and the variance are different. So in the next video, we are going to study how to handle that. It is not that difficult as long as you understand the standard normal distribution. Okay? See you later. Bye.